Volume of a cone, the special edition. So let's take this up a notch, and we're going to then meld in some stuff that we've already done this year. And I want to see if you can see this before I tell you. So we're talking about still the volume of a cone. And we talk about a cone, we're talking about that party hat, the bit of a funnel that does not include the tube. You know, we're talking about that type of shape. So let's just draw one right now. I'm going to start with the legs of this, my triangle, then my kind of half circle, and then in the back is my dotted circle. And then I'm going to draw in my vertical here. Okay, let me get my straight edge for my vertical so I can get this right. Okay, and then that. So first thing I'm going to do is I'm going to label it. And I'm going to label this 13 meters. Why not? And I'm going to label this in here 5 meters. Now, this is special because something's not given here. What we don't have is we do not have the height. We don't have the height. We don't know the length of that line. And what we have to do, though, is we can look to see, what do we know? Well, I know what the radius is. The radius is 5 meters. I know this line. Well, what's that line? Well, we haven't given a name to it. It's described as the slant height, the height of the slant of that cone. So we're going to say slant height is 13 meters. And then what we don't know is that one right there, right? The height. What we do know is, we do know how to find that, because don't forget what this relationship is. I'm going to write this in here. It's going to be so tiny, but it's that little spot that shows you it's a right angle. And because we know it's a right angle, I can take that triangle out of the shape and just draw it over here. And say this is 13. Let me draw it better for scale here. We can say this is 13 and this is 5. And this is, I'm going to change it to X just for the sake of mathematics instead of question mark. Okay, then what we've got to do is, number one, we've got to find the height. Before we even consider getting that volume formula out, we've got to know what the height is. Otherwise, we don't have the values that we need for that formula. So let's find the height. We take that right triangle out of there, kind of bring it out here. We've got a right triangle. Don't forget the right triangle. We're talking about the Pythagorean theorem now. And the Pythagorean theorem then is a squared plus b squared equals c squared. And then just for the sake of reminders here, we describe the 3 sides. I know that my longest side, or the side that's opposite the right angle, is the hypotenuse, which is always going to be c. Then I'm going to do the math. And the math tells me I have 5 squared a plus, let's make it b squared. We don't have to make it x. Equals 13 squared. Now, some of you who know your Pythagorean triples know that I picked those on purpose, so you already know what the height is, which gives me 25 plus b squared equals 169. We're going to take 25 away from both sides. And we're going to get b squared equals 144. And that's usually one where 8th graders go, ding, I know exactly what that is. But sometimes 8th graders go, dud, I'm not exactly sure what I'm doing here. So what we're going to do to solve for b, we don't want b squared, we just want b, is we have to take the root of this. So we're going to say, put it under the radical. We're going to add the radical there and say, what is the square root of b squared? So what times itself would equal b squared? Well, b times b is b squared. And then if we're going to use the square root here, we've got to use it on this side. And the square root of 144 is plus or minus 12, technically. But because we're talking about a distance, what we're going to use is just the positive version. So I'm just going to go ahead and erase this. So we found B is 12. Now don't forget what B is. B is the height of that cone. Because we have that, now we can go to the volume formula. And the volume formula is going to be really simple because we can go back into this, write our volume formula down. Volume equals 1/3 pi r squared height. I have the pieces, put the pieces in, do the calculation. 1/3 pi 5 squared, that's the radius, times the height. Then I get my calculator. And I go 1/3 times pi times 5 squared times 12 equals 314.15. Is my hundredths place 5 or greater? Yes. Then we're going to bump the tenths place up 1 and say this is a 2 meters cubed. And that's the volume. So if we're provided the slant height, the key to doing this is make sure you are finding the height of the cone first, then using the Pythagorean theorem, then going in and getting to your volume formula to find the volume of that shape. If you have questions, of course you could ask. Good luck.